Hello everyone, welcome back to Math 120 online course. This is Tongxiao Liu from Mathematics in Alabama A&M University. Today we're going to discuss section 2 of chapter 2. But before we do that, let me just remind you to purchase the Xcode from WebAssign. You can do it either online or from bookstore. There are about $100 per each. Once you have the Xcode, you can create an account in Cengage, and then you just access the WebAssign assignments from Blackboard. I have written documents and guidelines in Blackboard that you can read on how to do assignments online in WebAssign. Please read them carefully. If you have any questions, you can either send me emails or you can post the questions and concerns in Blackboard on the discussion panel. You can also call me if you want. Please, also read the announcements regularly because I usually post the important events and dates on announcements to remind you those events. So this is a few things that I need to talk about before we start. Today we're going to talk about the algebra of functions. When we talk about algebra, we mean sum, difference, product, and quotient functions. Just like we do numbers, we can do the same for functions. For example, if we have function f(x) equal to square root of x plus 1, we can easily find the domain of this function as from -1 to infinity. And that is because we require the inside of the radical x plus 1 to be greater than or equal to 0, so that we can take the square root. And if you solve this inequality, you get x greater than or equal to -1. In the interval notation, it will be the interval from -1 to infinity, including -1. There's another function gx in this example. It's defined as 2x plus 1, and this is a linear function, and the domain is all real numbers. In the interval notation, it's from -infinity to +infinity. So we can add those two functions to get f plus g of x. So that will give us square root of x plus 1 plus 2x plus 1. And the domain of these two functions is just the intersection of those two domains. Since we have the domain of gx to be all real numbers, we only need to include the domain of f in here. So the domain of this new function f of g will be from -1 to infinity. We can also do a difference of two functions by subtracting the two functions f and g. So in this case, we just change the plus sign to the negative sign, and we get square root of x plus 1 minus 2x minus 1, and the domain is also the intersection of those two functions f and g, which is again from -1 to infinity. And then we can also multiply the two functions f and g to get another function which is 2x plus 1 times square root of x plus 1. We usually write the square root part at the back. So the domain of the function again is from -1 to infinity, as we did for sum and difference of f and g. Now, how about division of two functions? If we divide those two functions, f and g, we're going to get square root of x plus 1 over 2x plus 1. Now we get the rational function, a part in the denominator, which is 2x plus 1. And we have to note that this denominator cannot be 0. So that gives us a restriction in the domain, which is x not equal to negative half. So then we need to take off negative half from the domain of f and g. And if you write the new domain of this function, it will be a union of the two intervals, namely at the interval from -1 to -1/2, union -1/2 to infinity. And there is another operation for functions. We call them composition of functions. The composition of two functions is defined as follows. Suppose we have two functions, f and g. The composition of f with g will be defined as f of gx. So what you do, you just replace the variable in f by the function g. Similarly, we can define g compose f to be g of f of x. So we're going to get the new functions in this way. And if you switch the order of composition, they're not the same in general. So f compose g of x is not equal to g compose f of x. Let's just do this example again using the same functions, f and g. F is equal to the square root of x plus 1, and the g is 2x plus 1. So when we compose f with g, we do f of gx as we defined. So that means we are going to replace x of f by g, which is 2x plus 1. So then we get square root of 2x plus 1 because we replace x in the f by the g. So if you can simplify the result, it gives us square root of 2x plus 2. Now if we do the opposite order of composition, g compose f, then we do g of 5 f of x. So what we need to do is just replace x in g by the f, which is square root of x plus 1. And that will give us 2 times square root of x plus 1 plus 1. So you can see the results from those two compositions are not the same. So this is for today. We're going to do 2.3 next time.